When you typically think of beetles, you don't think of things that can hurt you or that are particularly interesting. They just crawl around, you might step on them occasionally. But there are certain types of beetles that have a really famous defensive mechanism that actually can hurt you. They're called Bombardier beetles, and they defend themselves by detonating explosions inside of their bodies and spraying out hot, nasty chemicals. So hot that it's the temperature of boiling water. And so I study these beetles to understand, A, how they have these explosions happen inside their bodies, and B, is there things we can learn from that. Previously, people have looked at this by taking images of the outside of the beetle, so using high-speed photography to watch the pulses fly through the air. Whereas we are looking at the inside of the beetle using cutting-edge synchrotron radiation to visualize the spray being formed inside the beetle. So that allows us to see how these pulses, how the spray, instead of coming out as a continuous stream, comes out as a series of pulses. And what we find is that a part of the explosion chamber actually deforms during the explosion, and when it does so, it cuts off the flow of reactants into the explosion chamber. And so that causes the explosion to temporarily start or stop. Bombardier beetles are one of the most famous examples of chemical defense in nature, and people have been trying to understand how they produce these hot sprays for a very long time, and they've been trying to understand how these beetles have evolved. And our work really shows that something as complicated as a pulse jet spray can emerge from very simple modifications. The softening of a particular part of the reaction chamber can produce a huge change in the type of spray. If you look at these beetles' relatives, it comes out as a gentle mist, whereas in this case it comes out as a pulse jet.